Welcome to a deep dive into Elasticsearch architecture and its end-to-end workflow. Ever wondered how Elasticsearch drives lightning-fast, scalable search and analytics across vast datasets? Picture a dynamic web where data flows effortlessly, powering insights at your fingertips. Let's journey through the intricate web of Elasticsearch functionality. From indexing to querying, each step seamlessly interlocks to deliver real-time results. Imagine your data as finely tuned instruments in a symphony, harmonizing to reveal valuable patterns and trends. In the realm of Elasticsearch, data isn't just stored, it's harnessed, refined, and unleashed for actionable intelligence. Stay tuned as we unravel the powerful secrets of Elasticsearch's architecture and workflow, transforming raw data into valuable knowledge. Fast, scalable, and insightful, that's the promise of Elasticsearch. Get ready to unlock a world of possibilities in search and analytics. What is Elasticsearch? It's a powerhouse, a distributed, open-source search and analytics engine leveraging Apache Lucene. Picture this, lightning-fast, near real-time search prowess handling petabytes effortlessly. Originally for full-text search, it's now a go-to for log analysis, metrics monitoring, and more. With a RESTful API and JSON docs, it's a developer's dream. Think distributed search, real-time data crunching, and scalable analytics. Elasticsearch, where search meets speed and scalability. What are the fundamental architectural components that underpin Elasticsearch's functionality? These building blocks are the backbone of data storage, indexing, and retrieval processes. Picture them as the essential foundation supporting everything from basic text searches to intricate analytical queries across vast document collections. Let's break down these core concepts to unlock the power of Elasticsearch. In the world of Elasticsearch, clusters and nodes are the backbone of your data infrastructure. A cluster is a unified group of nodes, each with a designated name like Elasticsearch, working together to secure your data and balance the workload. Nodes, on the other hand, are the individual servers that store, index, and search your information. They communicate seamlessly to uphold the cluster's integrity, ensure data redundancy, and streamline query execution. Master nodes oversee the cluster status, while data nodes handle document storage and query processing. This division of labor allows for efficient scalability and performance optimization. Think of clusters as the team and nodes as the players, each with a crucial role in the game of data management and retrieval. Takeaway: clusters and nodes form a dynamic duo in Elasticsearch, ensuring data security, workload distribution, and optimized performance. Ever wondered how data is organized in your system? Enter indices, the data containers of your world. Just like virtual filing cabinets, these indices store and categorize documents with similar traits. Picture it like having separate drawers for customer details, product listings, and purchase records. Each index flaunts a unique name for sorting, finding, and updating data efficiently. With their tailored settings, indices are finely tuned for specific usage patterns. Packed with JSON objects, defined by mappings, and segmented into shards for distribution, these indices offer a structured haven for your data. Remember, index names stick to lowercase letters and steer clear of pesky special characters. Harness the power of indices for organized, swift data management. Ever wondered how Elasticsearch efficiently handles data distribution? Let's delve into the core mechanism, shards. Firstly, primary shards serve as the foundation, organizing documents into distinct storage units. Meanwhile, replica shards offer redundancy and enhance read performance by existing as exact duplicates on separate nodes. Automatic distribution of shards across nodes allows for seamless scalability, enabling horizontal growth by simply adding more machines. A typical setup includes 5 primary shards with 1 replica each, striking a balance between distribution and efficiency. In a nutshell, Elasticsearch's shard system ensures robust data management and optimal performance across your cluster. Ever wondered how data seamlessly flows from its source to the index in Elasticsearch? The data ingestion process is like a well-orchestrated dance, with documents undergoing collection, potential transformation, routing, indexing, and replication for resilience. Optimizing this flow is key for maximizing performance and troubleshooting any hiccups. Picture this: data entering a pipeline, choosing its path, and finding its place in the system. Understanding this journey is vital for smooth operations and efficient problem solving. In the world of Elasticsearch, the path from source to index is a carefully choreographed symphony of efficiency and reliability. When it comes to ingesting data into Elasticsearch, you have several methods and tools at your disposal. For direct integration, you can make use of RESTful APIs, allowing for seamless indexing of documents, whether it's single documents, bulk operations, or updates to existing data. Alternatively, Logstash serves as a robust data processing pipeline, perfect for handling data from various sources simultaneously. With over 200 plugins available, it excels in complex ETL workflows. Or, opt for Beats, lightweight data shippers that efficiently collect specific data types. FileBeat for log files, MetricBeat for system metrics, and PacketBeat for network traffic analysis. Their minimal resource usage makes them perfect for edge deployment. In a nutshell, whether you prefer direct API calls, leverage Logstash for intricate workflows, or rely on Beats for lightweight data collection, Elasticsearch offers versatile ingestion methods tailored to your needs. Ever wonder how Elasticsearch handles document indexing behind the scenes? Let's break it down. First, a JSON document arrives, and a coordinating node assigns it to the right shard. Then, the document's fields are processed based on the index mapping, text fields get tokenized, dates are parsed, and structures are optimized for search. The data moves to an in-memory buffer for Lucene indexing, where it's logged for durability and made searchable through a refresh operation. Once the primary shard indexes the data, the replication process ensures all replicas are updated. This intricate indexing lifecycle ensures data integrity and availability across the cluster. As a search query enters, Elasticsearch initiates a complex search lifecycle, transitioning from query to results. In a distributed search, shards efficiently handle two key phases, query and fetch. During the query phase, shards pinpoint matching documents and assign scores. Subsequently, in the fetch phase, actual document content is retrieved from relevant shards. This dual-phase process optimizes network traffic by transmitting only document IDs and scores initially, reducing bandwidth usage. The search phases encompass query parsing and validation, scattering queries to all shards, local query execution per shard, result gathering and merging, fetching full documents for top results, and ultimately delivering the response to the client. With this streamlined approach, Elasticsearch ensures a swift and effective search experience. What defines the schema of your documents in Elasticsearch? Mappings. They dictate how fields are stored, indexed, and analyzed. Text fields are for full-text search, while keyword fields store exact values for filtering and sorting. Date fields support various formats, with Elasticsearch internally using UTC milliseconds. Nested objects maintain relationships within arrays, crucial for complex data structures. Explicit mappings offer better control and performance than dynamic mapping. Use both text and keyword fields for versatile querying. Remember, mappings are key to optimizing your Elasticsearch setup for efficient data handling. What transforms text during indexing and searching? Analyzers. They break text into tokens and modify them. With character filters adjusting the text, tokenizers breaking it down, and token filters tweaking the tokens, analyzers are key. Standard, simple, whitespace, and language-specific analyzers handle the basics, while custom ones meet unique needs. Matching analyzers between indexing and search time is vital for precise outcomes. Text processing engines at work. Ever wondered how search engines understand your queries? Full-text queries like match, multi-match, and query string queries dive deep, scoring results based on relevance with TF-IDF and BM25 algorithms. For precise data handling, term-level queries, terms, range, and exists, work their magic on exact values, perfect for IDs, dates, numbers, and keywords. When things get complex, enter compound queries. Bool queries masterfully blend and, or, not, and filter logic, offering fine-grained control for intricate search strategies. From analyzing text to pinpointing exact values, these query types and interactions pave the way for smarter searches. In a nutshell, understanding query types unleashes the power of search precision. Are you optimizing Elasticsearch performance to its full potential? When it comes to performance considerations, remember to use the bulk API for efficient batch operations, adjust refresh intervals during heavy indexing, and tailor shard sizing to 20 to 50 GB per shard. Additionally, leverage ingest pipelines for pre-processing and utilize filter context for non-scored queries. Keep result sizes in check with pagination, avoid deep pagination, and employ doc_values for sorting and aggregations. Pre-filter with query context before aggregating, and monitor query performance using the Profile API and slow query logs to identify bottlenecks early. Stay ahead of the game and ensure smooth operations. End goal: optimize performance to enhance productivity. How can we optimize resource management for peak performance? Allocate up to 50% of available RAM to JVM heap, with a cap at 31 GB, balancing memory for Lucene segments. For shard size, aim for 20 to 50 GB each to avoid inefficiencies. Consider replica count. While standard is 1, high availability setups may benefit from 2 or more, boosting read throughput and resilience. Fine-tuning these aspects ensures efficient use of resources and enhances system reliability. How can we scale Elasticsearch efficiently? Horizontal scaling involves adding more nodes to boost capacity and throughput, with automatic shard rebalancing for load distribution and fault tolerance. In contrast, vertical scaling increases resources on existing nodes, limited by hardware and without enhancing fault tolerance. For optimized cost and performance, consider a hot-warm architecture to segregate recent and older data on hot and warm nodes, respectively. This strategy streamlines query capability while reducing expenses. Remember, choose the right scaling method based on your specific needs and constraints. Are you making the most of your cluster scaling strategy? Remember, it's crucial to plan your shard count wisely. Starting with larger shards can reduce overhead. Consider assigning dedicated roles to different nodes within larger clusters for improved stability and performance. Monitoring and adjusting using health APIs and tools is key to proactive scaling. Keep an eye on shard distribution, heap usage, and query speeds. Remember, it's better to scale up before issues impact users. In the world of clusters, foresight is key. Ever wondered how Elasticsearch brings together data from various sources seamlessly? In this comprehensive architecture, data flows from applications, logs, and databases through ingestion tools like Beats and Logstash. Master nodes oversee cluster state, while data nodes manage storage and queries efficiently. Coordinating nodes ensure client requests are routed effectively. This dynamic system processes and stores data across distributed shards, enabling near real-time querying and visualization with Kibana. The interconnected roles of master, data, and coordinating nodes create a robust structure for optimal Elasticsearch performance. Let's unravel the core insights from our journey. Clusters house nodes, nodes host shards, and indices group akin documents. Shards empower distribution and scalability, while replicas bolster reliability and speed. Mapping shape schema and field dynamics. In the realm of data flow, we navigate through ingestion, mapping, indexing, and replication phases, followed by querying, scattering, executing, gathering, and fetching actions. Anchoring text consistency are the analyzers. To optimize performance, embrace bulk operations, shard sizing best practices, caching advantages, resource monitoring, and workload-aligned refresh intervals. Delve into scaling strategies embracing horizontal expansion, strategic shard planning, specialized node roles for large setups, and cost-effective hot-warm architecture implementation. Let efficiency, balance, and foresight be your guiding stars in the data universe. Congratulations on completing this Elasticsearch journey. Now, it's time to take the next steps. Get your hands dirty with practical experience by setting up a local Elasticsearch cluster. Dive into indexing, mapping, and querying, using Kibana's dev tools for interactive exploration. Delve deeper into advanced topics like aggregations, script fields, and security configurations. The official documentation is your guide. Take your skills to the next level by building real projects, such as a log analysis pipeline or a product search engine. Apply what you've learned to meaningful use cases and solidify your understanding. Remember, Elasticsearch's strength lies in its flexibility and scalability. Keep experimenting, monitoring, and optimizing your solutions for efficiency and reliability. Mastery comes with practice. Keep pushing forward. In the world of Elasticsearch, the key is to keep exploring, learning, and adapting. The more you immerse yourself in its architecture and workflows, the better equipped you'll be to design effective solutions. So, keep challenging yourself and striving for excellence. Your Elasticsearch journey has just begun.